Okay.
All right. Well, good morning, everyone. If you're in North America, if you're in other places like the UK, good afternoon. Welcome. This is our first webinar of 2016 for the IFSM. And today we have Mark Johnson from Visual Law Group. Mark has been around some time, but he's actually sort of newly discovered to the IFSM. We met him at the last conference that we had in San Diego in November. And as a result of his presentation and his enthusiasm too, we've invited Mark to do a webinar. He gave a great presentation at the conference, and yeah, I'm just going to let him go right now because there's a bunch of material. As I said, please drop in your questions and we'll do everything we can. Mark, I'm going to pass it over to you for a little introduction, and again, thank you very much for doing this webinar for us.
Thank you, Eugene, very much. I'm glad to be here, and I really like to conduct these types of presentations informally, and I've asked Eugene to look at questions that are asked during the presentation, and he'll either save them up or give them to me as we go along. So, share with yourselves with whatever you want to ask. A real quick little background. I was originally a trial lawyer back in the Midwest for 14 years, working in Kansas City, and we handled primarily catastrophic injury cases with kind of a specialty of products liability and railroad collisions. Then in 1992 I moved to California and reinvented myself as a forensic animator, and I've been doing this for 23, 24 years. So the legal knowledge is way back in the background, but I've tried to focus on becoming more current on technology, and of course most of my clients are litigators, civil and criminal. We have kind of a specialty in transportation cases, although we do some criminal work with primarily shootings, police shootings and the like. But our biggest percentage of cases involve ground transportation and aviation, and again with railroad and trucking cases being high up in the list. What I want to do today is discuss the use of drone technology, and the title of the presentation is UAV technology for 3D visualization, and that's not quite accurate because some of what I'm going to show you is very definitely two-dimensional based, but I really want to try to open your eyes to the incredible technology that's available and adaptable to pretty much whatever you're doing. I know a lot of you that are attending the webinar today are actually working in the forensic field, but I also know a number of you personally are primarily involved in surveying or GIS endeavors, and some people that are doing aerial work and just interested in expanding their capabilities. So although we're going to be talking today in terms of some forensic cases, I want to emphasize again that the techniques themselves can be used in almost any industry, and the importance is to be aware of the limitations and be aware of the advantages, and that's what I'm going to be trying to focus on. So first of all, one of the biggest advantages that we have is that the techniques that we're going to be discussing are achievable with extraordinarily small investment. On the screen you see a Phantom UAV, and you can now pick these up brand new 4K resolution for under $500, and you can pick up a used one, the old Vision 2, for a couple $100 if you go on some of the user groups. To the right is the DJI Inspire. It's a more robust and more capable machine, and it's the one that we primarily fly, but a number of the examples that you see here were achieved with low-end drones, and I can honestly and truthfully say that every example that we discussed today could have been flown with the drone on the left or the drone on the right, or any number of other drones. So when you're looking at a capital investment, as opposed to spending $50,000 or $100,000 on a laser scanner, you can get some really achievable, usable three-dimensional point clouds and associated deliverables with an investment of $1,000 or less. So we want to talk about the output that we're delivering, and the first thing I want to mention are called ortho photo maps. Most of you probably understand these, but just real quickly, an ortho photo is simply a mosaic combination of images that is completely two-dimensional and scaled, just as though it was a survey plan. This happens to be the old Candlestick Park. They were, well, it's demolished now, but at the time of the demolition, they hired us to shoot a bunch of imagery of the stages of taking this thing apart. And this particular image, although it looks like a single photograph, it's actually comprised of 487 individual photographs that the software has stitched together to make an absolutely accurate two-dimensional ortho image, so that if you look at any given point in the image, you're looking straight down. And of course, the reason this becomes important in forensics is that you can put a ruler to this, and we could draw a line from here to here and measure it, and it would be accurate and to scale. So these become the basis of a lot of imagery that's used in accident reconstruction, because the ortho image itself can be used by the engineers or the attorneys or anyone else in court, so that you can determine 1 foot is 1 foot, 10 feet is 10 feet, no matter where you are in the image. Similarly, if we look at this next image, this is another ortho image, and you can obviously tell it's an ortho image because you can't see the sides of any of the buildings. We're looking strictly right down on the roofs or the footprints of the buildings, and this is, I can't overstate the importance of being able to get an accurate ortho image. And by flying a simple, inexpensive drone in less than 20 minutes, you can have an extremely high resolution, detailed image that is completely to scale and usable as a survey template, a survey tool, or in forensics for crime scene measurements or transportation reconstruction. Here's another intersection, again another ortho image. This particular image is up near Palo Alto, up in the hills, and there is a huge variation in topography, but everything is scaled according to an XY plane, so that you can measure from the roadway at any given point, and it's a projection as though you had a surveyor with a plan view of the intersection. Now, the second type of output is a three-dimensional point cloud, and here's two examples. The one on the left is a laser scanner, a Faro focus that we used, and to the right is a drone-generated point cloud. You can obviously visually see that the density of the point cloud created by the drone is much less resolution, but it turns out that in terms of accuracy of image landmarks, it's comparable in terms of accuracy to laser scanning, provided that you've set it up with proper control points, which we'll discuss a little bit later. Now, what we have found is in our work that we take out our laser scanner and we take scans of vehicles so that the accident reconstructionist can determine the degree of crush or the volume deformation, and that then of course is used to determine what the speed of the impact was. And it's not a cheap proposition to take out the scanner, to set up the scanner, and to get the output, where in reality we can send out a drone pilot with a simple Phantom drone, and in 10 or 12 minutes, these the images necessary to process and generate this three-dimensional point cloud can be done. So it's extremely efficient and less expensive to use drones to achieve this three-dimensional work. Now, I'm going to pull up the screen here of the software which we use, and which is, I would say without exaggeration, I think the leading purveyor of three-dimensional photogrammetric mapping. It's a company called Pix4D, and I've got the software running right now. And what we did was we flew a series of, I think, 397 images. The software has now stitched together the images and extracted the three-dimensional points. And it also, this particular software can generate a three-dimensional polygon mesh. Now I'm going to show you the difference right now. This is the point cloud, and you can see visually as we zoom in here all of the individual three-dimensional points that the software has calculated from the images. And then if we turn on the mesh algorithm, which I'll do right now, instead of points, the software has actually built individual polygons for the same area and the same photogrammetric three-dimensional scene. Now, obviously, as you can see on the trees here, you got a lot of artifacting because the software has to figure out how to make a three-dimensional object out of millions of points. So we end up doing a lot of cleanup in our own software packages. But because it is so much easier and less processor intensive to visualize things through a three-dimensional mesh, for us who are forensic animators, working with three-dimensional meshes is a lot simpler and a lot easier in terms of doing computer animation or display. So the beauty of Pix4D software is that it can generate both the point cloud and the mesh, along with some other outputs that are useful in surveying and mining and other industrial areas. This particular point cloud that we have on the screen right now is obviously a Prius that was involved in a multi-car collision, and we found by testing that the drone-based point cloud gave us equivalent measured deformation to using our full laser scanner. So now we have begun using drones as opposed to the laser scan in instances where we have to work quick or where we have a limited budget. The other thing that I wanted to throw out in terms of techniques, because most people that use drones for three-dimensional mapping are used to flying what's called a nadir grid, where you fly the drone like you're mowing the lawn over the top of the area that you're interested in. Whenever you're doing three-dimensional point clouds of objects, it's important that you fly oblique images in addition to the overall grid, so that you can get the detail that's on the sides of an object. Now,
hey Mark.
Yes, sir.
Sorry. On that image that you're showing, can you give me an idea of what kind of range you're talking about? Like what distance away is the camera from the vehicle?
Yes, that's a good point. This particular vehicle was at a salvage yard, and I put the drone up for the first pass, where I just flew about 5 rows horizontally and vertically, and I did that at 50 feet. Then I flew the drone at about 20 feet and did a series of orbiting 45-degree oblique images. And that's kind of the standard that I try to do. The other thing that I have learned recently to do is that when I'm done flying the drone and I land, I take the drone in my hand and I manually take photographs while holding the drone, because that lets me position it lower to get undercarriages and areas. And this is a technique that if you do this, and I highly recommend that you do, the only thing that's important is that you have to understand, for the software to put these three-dimensional models together, you have to have a minimum of 70%, 60 to 70% overlap of your images, because what the software is doing is using a computer vision algorithm. It's looking for objects that are common in more than 3 photographs, because if an object is seen in more than 3 photographs, the computer can locate where it is in three-dimensional space using the theory of parallax or perspective. So what you want to do is to make sure that you don't confuse the computer, and to do that you have to use either, you call it a breadcrumb or an ant trail, where your images are at all times linked up to other images that are in common. And so the best way to think of that is that you start with flying your drone in a flat lawnmower grid over the area you're interested in. And then when you're ready to do your obliques, you take a picture from the level of your overhead grid, lower the drone slowly, 5 feet, a couple stages until you get down lower, and have the camera pointed at an angle. And I call that a ladder, because you can think of it, you've done an overhead grid, and now you've brought the drone down slowly in a vertical level that matches to the point where you're going to be shooting obliques. And the software can easily then link all of those images together. If you just fly the overhead grid and then immediately start shooting oblique images, unless you have sufficient overlap, the software can easily get confused. So what I tell people is that you always do the overhead grid first, and then start working your way down from that grid. And if you need to change batteries, then you take your drone back up to that level. You just always remember what altitude you're at, and you can easily then, from any standpoint, bring the drone down to a lower level. And then when you're going to do the ground level images, the same thing. You bring the drone down from the oblique position. In this case it was 20 feet, pointing at about a 45-degree angle, and I would just snap pictures all the way down until I landed the drone on the ground, and then I could pick it up by hand and walk around the car. And all of those images then become an image base that creates these really useful three-dimensional models.
Hey Mark, we have a question from an attendee, and just to be clear here, you are in fact taking photos and not extracting frames from video, is that correct?
That's right. I would mention an interesting thing that I was talking to the good folks at Pix4D last week, and they advised me that they have perfected an algorithm that is allowing them to successfully extract this same level of imagery from video frames. Now, I personally, probably because I've done this so much, I'm comfortable flying these type of three-dimensional missions manually. I don't use autonomous flight, and I also am not interested in shooting video. But it's very clear to me that there are circumstances where it will be very useful to just let your drone fly, because by definition it's shooting, let's say 30 frames a second or 15 frames a second. The video frames are obviously going to always be overlapping at least, probably 98%. So the software should be able to have an ant trail that it can follow, and it probably is going to be a very efficient way to do this. So my understanding is that if that isn't available, it's going to be available shortly, and I would suggest that people go to the Pix4D site and search video, and I'm sure they've got a discussion about it, because I know it's something they've been working on. Now, another area that is important, and again, I want to make the point that everything that we're showing here comes from a single mission, and we're not shooting video, we're just shooting static photographs, and in most instances we're shooting between 100 and 400 photos for most of the stuff I'm showing you. You can, and we certainly have done projects where we've shot over 1,000 or 2,000 images, and the software can handle basically anything you throw at it. It just it tends to be overkill and too processor intensive to go crazy like that. But once you've got all of these images and you throw it into the hopper, so to speak, you can tell it, okay, I want an ortho image, I want a three-dimensional mesh model, I want a three-dimensional point cloud, and by the way, give me a contour map. So this next type of output is contour mapping, and of course, you've seen this with surveyors and their total stations, and in forensic work, it's very important to have a contour map in many instances so that you can actually see what the change in elevation is on this orthographic image. The image I'm showing you right now is from a project that, and by the way, those of you who fly drones and are looking for work, I can tell you that the high-end commercial air conditioning industry is very interested in talking to you. Turns out that if I'm a train installer and I'm putting 30 big air conditioning units up on a college campus, up until now they've had to deal with their planning by using Google Earth primarily. And what they have found is there's extreme amounts of error and artifacting and also just temporal errors because Google imagery is all over the lot in terms of the recency. So a guy with a drone can go out, and in this case we flew this the top of this building. You generate the ortho image and then you tell the software, give me the contour elevations. And of course you can see on the roof what the the crown of the roof is right here, and you've got basically runoff to the sides. But the air conditioning installer is extremely interested in seeing the roof topography as well as the current placement of equipment, because all of these lines and all of these installation fittings become critical to them determining what the job is going to require to do replacements. And they want to be able to do all of this without putting some poor bastard up on the roof doing an inspection, because that's expensive and requires manpower and also risk. So this is a very, very fertile area outside of forensics that we occasionally get called upon to do. But our general interest in topography for forensics is because in our transportation cases, lines of sight, slope elevations, these are very, very important elements in almost every case. And again, the ability to extract, in this case, this was a narrow mountain road where a bike and a truck collided, and it became extremely important to know the slope of the road because the bicycle was very dependent upon slope to determine its operation, and also because of the line of sight. So in this case, we couldn't fly the normal lawnmower grid because there was an absolute complete cover of trees. So the image that you see here was all generated by primarily handheld cameras and also by flying the drone at about 12 feet above the pavement surface while walking behind it. And it just shows you how adaptable this technology is. But when we were finished, we were able to generate an accurate contour map as well as the ortho image, and the engineers were able to use this successfully to reconstruct the collision itself. So contour imagery is often forgotten, but it's a very, very useful tool, and it's one that is available for the same price of admission. And that's one of the things that makes this so important and useful, because unlike a lot of the technologies, you do one thing, you go out and you shoot your photos, and then the software does all of the deliverables for you. We talked briefly about the difference between a polygon mesh and a point cloud. This is an example from a case where trucks and cars collided with bad results in a heavy fog. So to animate this particular scene, we flew the drone, we generated the point cloud, and then we had the software, the Pix4D software, generate a three-dimensional mesh. And the advantage, as I mentioned before, of having a three-dimensional mesh, for those of you who are animators, is that this is an extremely easy to to work with in your animation program, and you can actually put the camera down at ground level, and you won't see the artifacts of a point cloud, which are sometimes distracting. Now, this brings to mind one of the most popular questions that I'm asked about forensic animators who get into doing this drone work. They call me up and say, Mark, my road looks like crap. It's got all of these spikes in it and all this noise. And that's because the software algorithm obviously is parsing three-dimensional data from images that are usually taken, 50, 100, 200, sometimes 300 feet above the road surface. Once you get that kind of distance, you're going to absolutely introduce noise that's going to affect the flatness of your road. So there's a couple ways that you can approach that, and you can get flat surfaces. Probably the best way is, and going back into the Pix4D program here, you have tools that you can use to actually draw polygons on a surface that you want to be flat. And when if I want this street to be flat, absolutely flat, I could draw a single polygon and just tell the software when it generates the digital surface that it's a flat mesh. Now, in this particular instance, I wanted to have the crown of the road, and the surface details were important, so I didn't want to go that route. So instead, excuse me, to get the road surface flat, what we do is we generate the overall, I call it the lawnmower grid. Then we bring the drone down to about 20 feet, 20, 50 feet, and we fly at a 45-degree angle along the path of the roadway in both directions. And that high-resolution oblique imagery, combined with the high-altitude nadir grid, will dramatically improve the flatness of your road. If you continue to have issues and your road surfaces aren't flat enough for your liking, it's relatively easy to conform that in your 3D CAD software, or using an external program such as Geomagic Studio.
Hey Mark, can I interrupt you for a second?
Yes,
Sorry, just a couple of questions. So with respect to your flight path, in this particular instance, you're flying a grid, so you're flying at a particular altitude, taking all the images, you're coming down lower again, you're flying at 45 degrees in one direction, and then you're coming back in another direction. In the example of the car that you were talking about, and you talked about the 50-foot and 20-foot altitudes, are you flying a circular path? Are you spiraling down, or how are you approaching that?
I fly and I think Pix4D in their webinars, they give some examples of flying 2 or 3 orbiting altitudes. I tend to fly 1 or 2 circular orbits at a single altitude. So, for instance, for the car, I bring the drone down about 20 feet. I angle it at 45-degree angles until I have the car completely in frame, and then I just fly around the car slowly, keeping it in frame, so that you end up with what's essentially an ellipse close to a circular orbit. But the key for the software is to keep the car in frame as much as possible, so that you've got as much information that the software can translate. Then when the reason that I've adapted this technique, then I bring the drone down and land it, and then I walk around the car manually, snapping photos holding it down to get lower angles of the tires and the undercarriage. So that works really well for me. And I guess the other thing I should say, one of the things that's great about Pix4D is it's very forgiving if you give it enough overlap. And if you don't really care about the amount of processing you're dumping on your computer, you can go nuts and you can really overshoot it, and the software will produce beautiful results. We probably do overshoot too much, but we've got some pretty powerful machines, and I'd rather have too much data than not enough.
Yeah.
So
Another quick, sorry, another
yes.
quick question then, if I can.
Yeah,
In the
please.
case here, like when you're doing roadways and dirt and ground, they're usually very good for photogrammetry and for creating a solid structure. But in the case of a vehicle, if it's a polished vehicle, a glossy vehicle, and or even glass and that sort of thing, how does Pixar handle that, or how do you handle that if you can do anything to mitigate that?
No, that's actually a good point that you make. And if we look, and by the way, while I've got this on screen, just I was going to show you in this particular instance, we tend to fly our grids along the length of the area, and then once I finish this lawnmower grid, then I come down and shoot until I get to a lower point, and then I orbit the intersection shooting obliques. In this particular case, because we wanted the roadway to be flat, we then flew at the very low altitude, 15, 20 feet, and flew down the center line of each lane in both directions, shooting oblique, and then that really smoothed out the roadway well for us. But getting to your point about, let me turn this off. If we go back up here and we look at these, creating these objects, you'll notice where you get kind of the black, and obviously over the lights here, it's not registering enough points, so the point cloud is blank, and so you'll get objects. In this case, it's a pretty dusty car, and so it was no problem. As long as you have a little bit of surface variation, the software does really well. But if you have a brand new car or a very shiny surface, then yes, this is a problem. And so what I do, I went to Home or Office Depot, and you can buy these little packets of circular stickers, and they come in different colors. So what I do is I get a pack of those stickers, and for the areas of the hood or the areas of the windshield, if I don't have a dusty object like this, I just put I'll put maybe a dozen stickers on the windshield. The software will nail those points because they're very discrete points that are then able to be triangulated. And then all I care about, since it's a smooth surface, I just want to make sure that the resulting mesh is flat, and so I don't really care about putting too many more surfaces on the hood or the windshield, since they're they're a basic smooth curve. I just need to have enough points that the software can interpolate a mesh that is that matches the contour of the object. Let
Okay,
me turn off these
great.
stupid things. Okay. Now, here's another example of how we use in the real world the photogrammetry and the generation of drone-based three-dimensional visualization. This is a case involving a couple guys in a pickup truck that were minding their own business, driving down this highway, and some yahoos in a Ford Astro van turned left in front of them. Had a relatively nasty impact, but everybody would have walked away and been fine, other than the property damage, except for, as a result of the impact, the pickup truck was it came to rest square on a railroad crossing. We are looking right now at the video from the train, and you can see right there the pickup truck. Let me pause it here and I'll show you what we're doing. The pickup truck has come to rest right in front of us. This is one of those, talk about having a bad day. You just had a wreck and now your car is disabled on a railroad track. And just so you know, what we're looking at here, the original footage from the train is on the left. One of the things that we do a great deal of is, in our work, we take surveillance footage like this, and it's almost always inaccurate in terms of frame-to-frame intervals because of the way that surveillance videos buffer. So we will take the footage and then we will correct it in terms of timing. So on the right, if you want to look at this as I play this, it's probably easier to see the progress here on the right side. But as the train is coming up here, the pickup truck is disabled on the track in front of us, and I understand, guys, that you've probably not seen this play smoothly because of the nature of the whole webinar system. But trust me, you're not missing anything. I'm going to pause it to discuss the points. But as you can see, the pickup truck is stuck here on the track. The train is coming, and right before impact, we can see this gentleman is getting out of the car, and of course it did not end well. The driver and the passenger were both killed, and the issues in the case involved the fact that the locomotive did not blow its whistle, and so the big issue in contention was, had the occupants of the truck been given more opportunity to know the risk, they could have gotten out in time and saved themselves. So, you know, I'm not going to argue the merits of the case, and as a matter of fact, we never argue anything. We just illustrate whatever our clients hire us to illustrate. But in this case, the attorneys wanted to recreate this collision and to study what took place so that they could make this point about the importance of warning, because their position in this case was that the impact disabled the pickup truck, left them on the track, and they were disoriented, and as we can see, at least the guy got out at the last minute, but most likely they weren't aware of the danger they were in until it was too late. But this case was in Atlanta. There was a limited budget, and so what we do have is a network of drone pilots that are certified that we can seek that we can hire, sort of like, you know, Uber drivers. So I put out the word that I needed this area flown, and I had a nice, competent pilot from Atlanta go out, and then he, you know, spent an hour at the scene. I sent him a Google Earth with a rectangle saying this is the area that I want flown, and so he sent me 437 images, which then I processed, and then I generated a point cloud, a three-dimensional mesh. So what we're looking at here is the final mesh that I built, and I have added three-dimensional trees from our library, because you'll remember when we looked at the mesh before, those crappy looking trees at that one particular scene. It's a lot easier to be able to add some of these objects rather than try to clean up a mesh so that it fits. But we're looking down at the, you know, this is the drone created mesh, and I'm going to just real quick step through this so you can see we've got the pickup truck coming here and the van, and we're able to determine this collision both from physical measurements from skid marks, but also you can actually see, if you study the train video, you can actually see the van, and you can also see the pickup as it approaches. So the accident reconstructionist was able to get velocities so that we could reconstruct this collision. But after the collision, the pickup truck comes to rest on the track. And again, I'm not playing this smoothly just because we don't have the bandwidth, but if you see the actual animation, we're able to show the oncoming train accurately, and we were able then to build this whole scene out really quickly because the drone generated the contours of the ground accurately, and it also located all of the trees and signs and objects. We just threw away all that crap from the point cloud and dropped in our own better looking trees, and we got a functional animation that back in the day would have taken us a week to do, and we could generate a three-dimensional view, you know, in a couple of days, much to the delight of our clients and much to the delight of us for not having to slave over this as much as we used to have to do. But as you, because you now have the whole scene built in 3 dimensions, you're able to view the collision sequence from any number of camera angles. Now, let me take a moment to speak to those of you who do forensic animation. One of the most important things, well, probably the most important thing, is that what you do is foundationally accurate. But once you've established foundational accuracy, you really have to be a storyteller. And that's the beauty of this type of approach, because what you really are trying to do is to get the jury, or the judge, if it's a case tried to the judge, you're trying to get the viewer to identify with the themes that you're presenting and to have an emotional connection. So the purpose of this this exercise was to be able to let the jury actually get a sense of the horror and the terror, and you can see our little guy getting out of the car here. And all of this is foundationally accurate because it was based on the train video and the reconstructionist. When you do it this way, you can actually then tell the story and get really personal. I took some liberties and put the guy here looking at the train. That was kind of a liberty I got away with because we couldn't really make out what he was doing. But when you present forensic animation this way, you are able to give what, forgive my French, but it's called an oh shit moment. And I developed that phrase when I did actually a railroad case about 10 years ago, where we presented an animation like this, and and one of the jury members actually audibly said, "Oh shit," at this point. And so I've always used that. When you can provoke that kind of a response emotionally, you know that you've really connected. While we're looking at this, I'll make a comment. You can see how happy all this stuff looks in the background. This is the mesh that's being generated by the software. And this is a car. It looks like it's caught in lava or something. But the point being that when you use this approach, you're only concerned with the areas that are important to your visualization. And because we flew along the railroad track, we've got enough integrity of the track surface here. But I didn't really concern myself with all of this external stuff in the background. And when you play the video and you watch the video, you're not paying attention to that anyway. But the point is that all of these are accurate objects. If we went back into the to the original photographs, you could see that these objects equate with fence posts and railroad accessory boxes and stuff, and it's all demonstrably accurate. You just want to make sure that whatever is important to your case, the critical part of your intersection or your crime scene, that you've got enough resolution and detail. So here's another example that I think really illustrates the point of the importance of two-dimensional ortho images. And this is a case that, again, for those of you who aren't doing forensics but who are interested in this technology, there is a huge opportunity that is going to be, I predict, more and more prevalent, and that is involved in mapping transportation catastrophes without having to close down the roadway. This particular case took place on the Glendale Freeway when 6 cars collided, and it was a horrible mess. By the time the lawyers and engineers got involved with it, the case, it was like 3 months old. The California Major Accident Investigation Team had already been out and had closed down the freeway at great expense, mapped out all of the positions, and you can see here the orange spray paints that's from their survey at the scene. Now, they spent, because it was the state of California, of course, it just came out of our pocket, the taxpayers, but the amount of money that it costs to close down a freeway makes it cost prohibitive, to say the least, for basic peons like you and me. Furthermore, even when you're talking about the state or a municipality, the cost in terms to the community is drastic. So law enforcement and municipal planners, they want to do anything possible to not have to close down a roadway. And this is a good example of how you can get all of the information and more without having to touch the roadway at all. And we do that by flying the drone. In this case, it was a cheap Vision 2 Phantom, and as you can see, the camera itself is a fisheye lens, and you would think that this would be difficult to use, but it turns out that a GoPro camera or an old DJI Vision camera is absolutely fine to do the software 3D reconstruction that we're talking about, because the software is able to correct for the lens aberration. So these are a series of images. We flew the freeway. It was a rush hour morning, and we did 3 passes, flew the Phantom, brought the software, brought the images back and processed it with the software. And this is one of the ortho images, and you can see how we can make out the skid marks exactly. And what's important here is that if you think about it, the way this software is working, it is measuring objects that it can identify in 3 or more photographs. Well, all of those cars that are driving while I'm shooting the photographs, they're never going to be in more than 1 frame, because by definition they're moving, and moving at a fast velocity. So the software is able to extract a complete clean freeway. And the point cloud is as though it was on a Sunday morning with the freeway closed. But in fact, we were doing this right in the middle of rush hour. So this is a critical point that a lot of people don't pay attention to, and that is that when you go to an accident reconstructionist and they've got a scene that involves a roadway, a traveled roadway, it's a real difficult challenge to figure out how to get that data with a total station, or you can certainly take a laser scanner out and then clean up the cars afterwards. But a drone, a simple cheap drone, was able to generate a completely survey accurate image, completely clean, that the reconstructionists could extract all of the physical data, the gouge marks, all of the paint marks from the mate team, and needless to say, the engineers are now a believer, and they want a drone flown every time they have a major accident. Let's see, we are running out of time. Jim, you know what, I see we got about 10 minutes left. Do we want to take some specific questions?
There were a bunch of questions here, so let me start with some here that were at the top of the list or asked before. In terms of one question here, it has to do with the render times for some of the larger project, and it says, does combining nadir and oblique images increase rendering time? And I guess he might be talking about Pix4D.
Yeah, and of course, let's be honest here. Pix4D is not the only game in town. They just happen to be the best game in town, in my opinion. But anybody who is doing work with drones is aware there's software called Photomagic. There's Autodesk has its own software, Recap. There's a lot of image-based modelers out there, and more time, but they all are essentially using the same process of analyzing and spatially triangulating individual points. So by definition, the more points you have, the more processing time you have. By adding the oblique images, you are bumping up your processing time, but probably not dramatically more. The bigger issue is the number of photographs you're processing. The oblique imagery itself is primarily adding processing time because you're adding additional photos that have to be processed, compared, and then aligned by the software. In terms of, to be honest with you, the stuff that we do, I've developed a workflow that I bring the images home, I set up the Pix4D file. I get it running at the end of my day, and then I've got all the deliverables in the morning. But you know, a small project I can get output, you know, in an hour or two. But I tend to overshoot and to you know, I'd rather have too much data than not enough. So I've just taken the point that, you know, if I've got you know, if I've got 8 hours overnight, I can have everything I need in the morning in terms of the ortho imagery, the point clouds, and the meshes, and then I'm ready to get to work.
Okay, Mark, if you had to go back, or if was it possible to add images at a later time?
Yes, as a matter of fact, I've actually flown the same intersection on different days and more than a week apart. The only critical image being that the software isn't going to be able to match anything that it can't find in all of the images. And if you have something where, like, if road stripes are repainted, you're going to have you're risking some artifacts. But as a practical matter, you can do a couple things. You can take 1,000 images and cull out 300 of them and run a solution. And if you don't get what you want, you can throw more images from your original set at it. Another thing that I really do need to mention is this is really critical. The way the software works, it only uses JPEG images. You would intuitively think, well, heck, I'm going to go out there and shoot a raw PNG or a DNG file. Well, that's overkill. The software is only concerned about the relative pixel resolution. So always shoot JPEGs. Always turn off the raw image option, because you only are going to want to be feeding JPEG imagery. In terms of the discussion about processing, I can tell you that if time is of the essence, you know, I can shoot. And well, let me just give a call out right now. Pix4D has a free application that you can put on a smartphone, and it will control your drone, and it will shoot all of the imagery for you, and it'll handle the overlap, and it'll do so as efficiently as possible. So if I have a given intersection and I want to take out my smartphone and I press the button to go the rectangle that I've drawn around the map, the Pix4D will handle that, and it will shoot a lean and mean collection of photos that I can then process in a short period of time. It also has an option that I can fly my own obliques, and it will take pictures automatically when the drone moves the distance necessary to give it the 60 to 70% overlap. It's a very slick approach. It's called free flight. So I highly recommend, for people that are getting into this at the outset, I really recommend download the phone app. It's absolutely free. You can fly the complete image. The drone will do it automatically, and that becomes a really good tool, because you can then see what mathematically is the optimum way that that particular location should be flown. And then when you move on to doing your own manual flights, you can use that as an experience to know, well, okay, I've already seen how the software does, you know, 30 images down this row, you know, well, I'll fly, you know, 30, 40 images myself. But it's a very, very useful tool, and it removes all of the guesswork, and it allows you to choose the altitude that you want to fly at, and it will then adjust the distance for snapping the photos accordingly. This is very, very, very cool. I also highly recommend that you go to pix4d.com, and they have really, really good video tutorials. I also need to mention that, and I'm not sure what the pricing algorithm is now, but they have either buy the whole thing outright, or it's more efficient to just pay for a monthly license to process it. They will allow you to use their software absolutely free. You can go out in the field, you can shoot all the photos, you can bring everything in, and the software will process everything. It just isn't going to give you the final deliverable unless you have a license. And the way I suggest to people is, heck, use the software, go out, do 3 or 4 cases, and then pay the pay the $100 or whatever to get 30 days and process the imagery, and then you can and it becomes really cheap. You can then just amortize it among the cases that you're working on. But you'll find I'm not advertising Pix4D, but I really am a fan of the software, and I guess you would consider me an evangelist because it's allowed me to do things that we couldn't have done just a year ago.
Hey, Mark.
Yes.
I'm getting some feedback here. Some people, I think, they want us to continue past the hour. So, are you okay with time? You can hang out for a little bit longer. Okay.
Sure.
I'll tell you what. I'm going to ask you maybe a few questions just to knock some of these off the list, and then maybe if you can continue with your presentation after that. Is that okay?
Sure.
Okay. One question here is if you can just state quickly what the UAV camera and flight control software is that you're using again.
Yes. And the software itself is platform agnostic, but they do have, and as a matter of fact, when you go to their website, you can see they actually have some individual packages for some high-end drones. But for the people like me who are broke and have to do this stuff on the cheap, I go to my good old DJI drone store, and I highly recommend the Phantom 3. It comes in 3 or 4 flavors. The cheapest is $499, and then the most expensive is about $1,200. I really highly recommend that because that camera is great. The software is super. It comes free. The flight control software is downloadable for free. The other drone, and if you really want to, step up your game and have the best capability for a portable solution, is the DJI Inspire. That's the one that I want. The Phantom, it's called the DJI Phantom 3, and I think the low end, which shoots 4K video and full resolution still images, is I think it's $499. But if you go to DJI.com, you can see all of their drones and all of the flight software comes free with the drone.
Is there a name of the phone app from Pix4D?
Yes. The phone app, that if you go to the App Store, whether Android or iOS, and just search for Pix4D, Pix4D, you'll find their software. I would also mention there's another very fine company called Drone Deploy, and they have their own software that will do essentially the same thing we're talking about here. And as a matter of fact, I have a number of friends and associates who really swear by their technology. So by all means, again, their software is free to download. I think they give you like a 30-day trial, and then if you want to keep using it, they have a small monthly fee to license it to do, I don't know, 4 or 5 3D maps a month or something. Very, very economical. Drone Deploy, and you can either go to dronedeploy.com or go to the App Store or to the Play Store and search Drone Deploy. To be honest with you, I expect in the next 6 months we're going to see half a dozen or more of the very same thing, because when I've gone to the drone conventions, everybody has recognized this is hot. So if you keep your eye open, and for that matter, if you join the laserscanningforum.com, all of us geeks hang out there, and whenever there's a new toy, we talk about it. So I would highly recommend that as well.
Okay. I'll tell you what, Mark, let's let you go a little bit more. Maybe we can show another example or two, and then we're going to go back. We're getting overwhelming amount of questions, which is great. So.
Okay, let me move to, this is, I want to talk about really practical tools, and we've been talking at the macro level, which is, creating 3D models of cars. We can go really the micro level. We can go to the macro level. In this particular instance, we have a plane that crashed near Gilroy and Hollister, and we wanted to create the terrain and to recreate the plane crash itself, and it would have been impossible for us to use our little ground laser scanner because we needed to cover, more than a square mile or two. Well, we were able to take the little, and in this case, we ended up using the little Phantom, and the reason we used it was because the Inspire wouldn't lift off. It had some sort of glitch. That's another good reason to have a cheap drone in the trunk. When your high-powered, high-dollar model doesn't work, you can always have that $500 Phantom in the trunk, and you can get the work done. So we would have been up a creek, but we luckily had a couple Phantoms that we were able to fly. In this particular instance, we're looking at the point cloud that was generated, but we were actually parked right here. You can see a little blip. That's our pickup truck, and the plane crashed right down here. What actually happened in this case was a Cessna 140 was flying down this valley, and there happens to be high tension wires that snagged the wing and caused the collision and the tragedy that followed. The big issue in the case is to try to determine visually what the pilot saw. And before this technology was available, we would have either gone to great expense to hire a helicopter, and then we would have flown this with a camera, and then we would have, and even doing that, we would have been limited in how close we could get to those wires. But it turns out that this drone technology is extraordinary. We were able to generate this whole accurate point cloud for just being out at the scene, for a couple hours. So once we have the point cloud, as I mentioned, as an animator, as much as I love point clouds and I think they're sexy, we prefer working with 3D meshes. So I told Pix4D, give me a mesh. And so here is the mesh, and you can already see it's there's no holes. It's visually it's quite stunning, and we're able to get, I think in this particular instance, this whole territory is about a square mile and a half, or just short of 2 miles. But that's enough territory for us to then be able to animate the events. But for me to show all these objects in the far distance, I've got a problem, because even at 1.5 miles, I'm going to see the truncation of this valley here. So one of the really, really neat approaches and tools that I would recommend to you is to go to good old Google Earth, which is now free. And there is a plug-in for 3D Max called Terrain. And if you go Google 3D Max Terrain plugin, you'll find it. It's just probably the most useful plugin I own. What this does, it lets me open up Google Earth, and I can draw a rectangle around as many miles as I want, and the software will automatically generate a 3-dimensional mesh based on the Google Earth data, the terrain data, which is actually quite good. Now, it's much lower resolution than what we were able to achieve with the drone, but as long as I'm mainly concerned with looking at this far distance, it doesn't matter. It's perfect. So what we did was we generated the terrain with Google Earth, and then we combined and dropped in the high-resolution drone terrain right in the middle of it. So now when I put my virtual camera flying down this valley, I see all of this stuff in the background, which is accurate. And how accurate is it? Well, here is the 3D model. You can see the Google Earth terrain is kind of a slightly different shade. This is the actual frame from the video from the drone. So for purposes for us as an animator, this is more than good. This is plenty of fidelity for me to use this to develop some demonstrative evidence. But to really get the point across in terms of what the pilot saw and couldn't see, we went and positioned the drone right up at the wires. And so here I'm going to go. These are the wires that the pilot hit, and this is the altitude that the pilot hit them. But because I positioned the drone here, and then I turned on the video and I flew backwards, I can then simulate, and I'm just stepping through this because we can't play it smoothly on the webinar. But as you can see, I don't have to get very far back before those wires disappear. So now I fly all the way back up the canyon, and I come back to the studio. I reverse the footage. I then retime it to be 140 miles an hour or whatever the flight time of the Cessna was. And when you play this footage, you can see, you absolutely cannot see either of the high tension wires. They're the poles. They're hidden behind the terrain, and you can't see the wires themselves until less than a second. I think it's actually 3/4 a second. So the point that this makes is, and frankly, it is why the law requires those big marker balls on high tension wires if they're anywhere. I think they have to be wires more than 300 feet above ground, or any wires that are in a traveled flight path. So this turns out to be a project we couldn't have done without the drones. At any amount of money for us. Now, those of you who are a little more advanced than me and have bigger budgets, you say, well, what the hell, I'll just get a LiDAR and fly it. Yeah, that's right. Well, I don't have $17,000, $20,000, so I have to get my little Phantom out and fly this stuff. And the results are totally foundationally accurate, very usable, and my clients can afford it, and I can make a buck too. So it's really, really a useful tool. Now, I'll throw another plug in here. Faro makes a program called Reality, and it allows you to work with both point clouds and meshes in real time. And so what I did was here I brought the same mesh that we were looking at. I brought it into Reality. I brought a little three-dimensional model of the Cessna, and I'm able to actually set up and fly the plane through my valley. I even threw on a little fog effect here to simulate late morning fog, but it just shows that here's a great tool that if you're working with point clouds, or if you're working with point cloud derived meshes, for forensic investigators, this tool made by Faro called Reality is really useful. The reason being that everything comes in scaled, and I can bring in pre-made models of any automobile, most emergency vehicles, trees. It's basically an animator's toolkit, and it's designed for people who aren't professional animators. So a lot of the municipalities, a lot of the reconstruction firms are buying this software, and then they're bringing in their laser scans and their drone generated point clouds and working with it in this tool. I wanted to show another little example of how drone technology can be useful. This is an interesting case. Two families shared a driveway, and let's just say a feud had been running for several years, and there was a big about who was encroaching on whose property, and at this particular occasion, an argument breaks out between the two homeowners, and they have an argument. They come to blows here, and what's going to happen? This is a surveillance video that was shot from one of the residences, and don't worry if you can't see this play smoothly, because we're going to step through it in a minute. But what's happening is the wife of one of the gentlemen is standing here. These guys are just kind of like old walruses. They're not really hurting each other. They're just kind of flailing at each other. But unfortunately, the terrain on this driveway is a relatively steep slope, And so these two gentlemen are going to come down and bump into the woman, and when she goes down, her head hits the concrete and it's all over. And then this ends up resulting in a manslaughter charge against this gentleman. And we were hired to defend, and the theory of the prosecutor was that this gentleman pushes her as he's coming down the hill. So one of the problems is that what you're seeing here is an enlargement from the surveillance video, and because whenever you enlarge the center of a photograph, and it doesn't matter what camera you're using, whenever you enlarge a center, you're doing the same thing as making it a telephoto lens. The focal length is changing, and by doing that, you're also reducing the apparent distance between objects along the line. You know, the most famous example is whenever you see those great shots of the hills of San Francisco shot with a telephoto lens, it looks like the cable cars are on a ribbon going up and down, very exaggerated. That's because it was shot with a telephoto lens. Well, in this particular instance, our position was that you can't use this to accurately determine where any of these people are, particularly with regard to the distance along the line of the camera. So we went out to the scene and we flew a drone and generated a three-dimensional replica of the terrain, and more importantly, we were able to locate the surveillance camera is right here under the eave of this house. Once you create an accurate three-dimensional scene, and if you know where the surveillance camera is located, you can accurately create a three-dimensional replica or a virtual camera. When we did that, we analyzed the shadows, which you can see here, and we analyzed by using the shadows, we could spatially locate the actors, and then these are projection lines from the center of the lens that we use to make sure that our objects are accurately positioned, because there is one and only one place that everything will match exactly. So the more accurate you can be by projecting planar lines from your virtual camera, the more foundation you have for your case. In this particular instance, I put colored crash dummies that are matching the joint positions of the actors. So what I'm going to do is step through this, and what we discovered by studying the shadows and the body positions, this gentleman in red, who is the guy here in white, he is actually the one who comes into contact, albeit inadvertently, but the fellow in green, the guy who's being charged, doesn't actually come in contact with her at all. As a matter of fact, it is a motion between this guy, his hip, and hers that dislodges her balance. And so the theory in this case was that number one, he didn't have an intent, but more importantly, he causally was not acting. You know, their opening statement was that you're going to see that gentleman X actually stiff-armed the decedent, and that just didn't happen. And you can see why they thought it happened, because if you don't understand that this is a telephoto lens, it compresses the distance. It looks like his elbow and hand come in contact with her, when in reality they didn't when you study the shadows. Now, another real quick just point of interest, when this video plays, some of the frames are tinted red. The reason for that is that you'll find most surveillance systems are really crappy, and they're mainly concerned with collecting a great deal of information over a great deal of time, in this case 24 hours. So to do that, the software in these surveillance systems collects images in a buffer, and then it writes the images to a hard drive media later. But because of the nature of the system often gets ahead of itself or behind itself, and so to maintain accuracy, it will either throw away a frame or it will repeat a frame just to keep in sync. So what we did was we marked in red every time there was a duplicate frame. So when you play the footage, you can see that there are many instances. You know, this information, although it looks like it's here, it's actually missing. This is just a duplicate frame, and that became important in the case. I won't go into it right now, but the beauty of the system is that we can now view the incident from any view, and we can replay the incident and decode or decipher what is a single camera view and one that is misleading.
Hey, Mark.
Yes.
We're like 20 minutes over right now, but I was wondering if in the remaining time we could just maybe address some questions regarding some of the regulations and that sort of thing, because there's a few questions regarding that.
Yes, and let me address that real quick, because I don't want to get into a heavy discussion about regulations, partly because it's extremely screwed up and in flux right now. What I would suggest to all of you who are interested, and certainly you can and should contact me. I hope that my email is readily available. But there are registered pilots. We have a whole network of them who have their FAA Section 333 authorization to fly commercially, and will do so at a greatly efficient, reasonable cost. So if you don't want to fly yourself, and you don't want to go to the trouble of getting your own Section 333 registration, I can hook you up with pilots all over the country. You know, like the example I showed you. I had a case in Atlanta. I needed to fly it. If it's a case out here, you know, we have our own stable of pilots who are certified and registered. But I can get a pilot anywhere in the country at a very reasonable rate, because all we're asking of them is to fly a relatively simple, definable pattern. And any pilot who is reasonably competent can fly these images, which they upload to Dropbox, and then you can do the processing yourself, or we can do it for you. But the point on registration that I want to mention is it's very controversial right now. Right now, I think you've probably all heard that if you got a drone, you have to register it with the FAA. I think February 1st is the deadline, and there's a lot of people who are absolutely adamantly refusing to register. It's free. Well, no, I guess it's not free. How much is it? It's $10, $5, whatever. Yeah, I've got mixed feelings. I think we'll go ahead and register, just because I don't want to get into an argument with the FAA. But the truth is, and I think this is the takeaway, rather than get into a real detailed discussion about how to get your Section 333, and you can certainly Google that, I think, and most of the people that I agree with believe before the end of this year we're going to have a new set of regulations that are going to be simplified and that are going to essentially allow you to fly with basically some minimal online education, kind of like an online boat test. But right now, to answer the question, to theoretically fly commercially, you need to be registered and have your Section 333 exemption from the FAA. If you want to ask specific questions, go ahead, but I really think at this point it's not going to help too many of us, because there's 100 ways to get this technology incorporated in your work, whether or not you decide to fly. And certainly, I would have to be honest and tell you, there's a lot of people out there flying who aren't necessarily observing the rules, and their approach, you know, maybe it'll bite them in the ass, maybe it won't. But my focus right now is on the technology, and if you are interested in getting this done, by all means send me an email or give me a call. I can give you our experience, and I feel very strongly that this is technology everybody should incorporate and should use, if you're in the forensics or the surveying field.
Okay. Yeah, there's a lot of other little comments that people are posting. I don't know. It seems like we probably kind of need a separate webinar just on the FAA
Yeah, that'd be a good
guidelines
idea.
and rules.
There's we have a couple pilots that, as a matter of fact, one of our friends is a United Airlines pilot, and he is an advisor to the FAA, and he is also a very avid drone pilot. And we could very definitely have him participate in a workshop on this. If people are really interested in that level, the FAA compliance, we can make that happen. And certainly, they probably should be. But I just want to get the work done, and I'll pay somebody to do it as needed. And it's really it's in flux right now.
Okay. Well, I'll tell you what, Mark. It's getting close to 12:25 here on the Eastern Time, and I know some people are probably going to have to drop off. Although we still have a whole bunch of people that are here asking questions.
Well, I'm really grateful, all of you that have hung in here. And I know I'm not the most polished guy, but I hope that the information is at least useful and interesting.
Yeah, I just want to remind everybody that we will definitely post this webinar on our website. If there's more demand and everybody says, hey, we need to do another one of these things on this particular topic, it's because it sounds like it was interesting for a lot of people who are either already doing this type of work or looking to embark on this type of work. By all means, let us know, send us your comments. Also, there's a number of questions that we did not get to. Mark, I believe, has dropped in we've dropped his email there if you want to contact him directly, or feel free to contact us at info@iafsm. Is it org now? I'm getting confused if it's .org. But we have some. It's .org. Okay, good. So info. Let me just type that in here so everybody has that. ifsm.org, and we'll do what we can to tabulate the remaining questions and then get back to everybody. So on that note, Mark, thank you very, very much. It was a great talk, a lot of good interest. We'll definitely have to have you back. And to everyone who's attended, thank you very much, and look for the webinar on the IAFSM website. Thanks, everybody. Take care.